Welcome to a new era of computing where quantum computers are rewriting the code of reality. As we take our first steps into this uncharted territory, it's essential that we understand the fundamental building blocks of this technology, quantum bits, or as they're more commonly known, qubits. Now you may be familiar with the classical bits used in the computers of today. These bits are binary, meaning they exist in one of two states, 0 or 1. But here's where qubits shake things up. Instead of being limited to a single state at a time, qubits can exist in multiple states at once thanks to a property known as superposition. Picture it like this. If classical bits are a coin that is either heads or tails, a qubit is a coin spinning in midair, representing a combination of heads and tails until it lands. This ability to exist in multiple states simultaneously opens the door for parallel computations, a feature unique to quantum computers. But that's not all. Qubits also harness another quantum phenomenon called entanglement. This means the state of one qubit can be intrinsically linked to the state of another, no matter how far apart they are. This connection, this entanglement, allows quantum computers to process vast amounts of data in ways that our classical computers can't even fathom. This ability of qubits to exist in superposition and their entanglement with each other allows quantum computers to perform complex calculations at unprecedented speeds. It's a game changer, a paradigm shift that has the potential to revolutionize how we process data. This is fundamentally different from classical bits and marks the beginning of a new era in data processing. We're standing on the precipice of a technological revolution where the rules of the game are being rewritten by quantum bits. The future of computing is not just binary anymore, it's quantum. Now let's delve into how quantum computers promise to speed up the solution to complex problems. Imagine this. You're standing in front of a massive labyrinth, and you're tasked with finding the quickest way to the center. With a traditional computer, you'd start at one entrance and try every possible path one at a time until you find the quickest one. This could take a long time if the labyrinth is particularly complex. Now picture the same scenario with a quantum computer. Instead of trying each path one by one, a quantum computer can explore all possible paths at the same time, thanks to the unique properties of quantum bits. This allows it to find the quickest path in a fraction of the time a traditional computer would take. Our guest today is a developer of quantum algorithms who can shed light on how this is achieved. Quantum computers leverage the principles of superposition and entanglement to process information in a fundamentally different way. This ability to process multiple outcomes simultaneously gives quantum computers a significant speed advantage in solving certain types of problems, such as factoring large numbers or optimization tasks. For instance, factoring large numbers is a cornerstone of modern encryption techniques. Traditional computers struggle with this task as the numbers get larger, but quantum computers could potentially solve these problems much faster, rendering many current encryption techniques obsolete. Similarly, optimization problems, which involve finding the best solution from a set of possible options, can be significantly accelerated through quantum computing. This is not to say that quantum computers will replace traditional ones. Instead, they will complement each other, each excelling at different types of tasks. Quantum computers will be particularly useful in areas where we face complex problems that require heavy computational power, such as drug discovery, climate modeling, and financial modeling. This means we are on the verge of a computational revolution. The era of quantum computing is dawning, promising to accelerate computations and open up new possibilities in data processing and beyond. The quantum future is not just about faster computations, but also about solving problems we couldn't solve before, and perhaps even redefining what we consider to be a problem. Despite the potential, quantum computers face several technical challenges. Stepping into the realm of quantum computing isn't just about harnessing the power of qubits. It's also about overcoming some significant hurdles. One of the most prominent is maintaining qubits from external influences, a challenge that our technology experts are working tirelessly to overcome. Qubits, unlike their classical bit counterparts, are incredibly sensitive. They can be easily disturbed or decohered by their environment, often leading to computational errors. This phenomenon, known as quantum decoherence, is one of the most significant obstacles in our journey towards fully functional quantum computers. But it's not all doom and gloom. As we've seen time and time again, technology has a knack for overcoming seemingly insurmountable challenges. The field of quantum computing is no exception. Researchers are exploring a range of solutions to tackle quantum decoherence, from developing new materials that can better isolate qubits, to creating error correction codes specifically designed for quantum systems. Moreover, as quantum technology continues to advance, we are also beginning to see the development of hybrid systems that combine the best of classical and quantum computing. These systems, often referred to as quantum-inspired computing, have the potential to solve complex problems much faster than traditional computers, even while we continue to fine-tune the performance of true quantum machines. We are at a fascinating juncture in the timeline of computational evolution. Quantum computing, once a concept relegated to the realms of science fiction, is becoming increasingly tangible. And while the road ahead is filled with challenges, it's also brimming with opportunities. With the advancement of technology, we can overcome these obstacles and witness the dawn of quantum computing. As we continue to push the boundaries of what's possible, we're not just rewriting the codes of reality, we're also laying the groundwork for a future where our capacity to process and understand data transcends anything we've known before. We are just beginning to understand how quantum computers will change data processing. These extraordinary machines with their quantum bits or qubits have the potential to revolutionize computations by existing in multiple states simultaneously. This allows them to perform parallel computations, marking a significant shift from the traditional binary bits. The promise of accelerated problem-solving that quantum computers bring is indeed exciting. Complex tasks, such as factorization of large numbers or optimization processes that once seemed daunting, can now be solved in significantly less time. But as with all groundbreaking technologies, quantum computers face their own set of challenges. Qubit preservation, for instance, continues to be a technical hurdle. Yet the rapid pace of technological advancement gives us hope that these challenges will soon be overcome. The dawn of quantum computing is upon us, blending science and technology in a bid to rewrite the code of reality. Thank you for joining us in this exciting exploration of the future.